It is very easy when map reading to become so involved in navigation that other flight deck management tasks suffer. We are therefore going to show you a map reading technique designed to minimize cockpit workload so that the solo light aircraft pilot has time to carry out such other tasks as flying accurate headings and speeds, regular engine, electrics and suction checks, radio calls, fuel management and, most importantly, lookout. There are two basic methods of map reading. One is map to ground. This is the preferred technique, which involves a low workload. However, it does require pre-flight preparation. The other is ground to map. This is a fallback technique, normally only used if the primary method leaves us uncertain of position. We will illustrate map to ground technique with a typical PPL VFR triangular route, which consists of 3 legs, each of about 20 minutes. Once the route has been drawn up, choose some easily recognizable ground features at intervals of about 5 to 10 minutes flying time. When the navigation flight plan has been completed, we will know the planned ground speeds for each leg. We use these to calculate the time in minutes and seconds to each fixed point. It is then extremely important that we start the stopwatch at the beginning of each leg and fly the planned headings and airspeeds accurately. Now, simply let the watch run until about 2 minutes before the planned fix point. We use this time to confirm our heading and airspeed, concentrate on accurate flying, make radio calls, monitor our fuel, think about the nearest diversion, carry out systems checks, and keep a good lookout. The watch acts like a car mileometer. When we have 2 minutes to go to the fixed point, this is the time to start looking for it. Typical light aircraft ground speeds are around 2 miles a minute, so it should be approximately 4 miles in front of us. If it is large and conspicuous enough, we will see it. As we pass a beam or overhead it, we check the time to see whether we are running early or late. We also make a track adjustment, if required, using one of the techniques covered in the lesson on the 1 in 60 rule. We repeat the technique at the next fixed point until we come to the end of the leg. We then restart the stopwatch at the beginning of the next leg. The ideal visual checkpoint will be recognizable from some distance away and will have the following characteristics. It should be large so that it can be quickly seen and recognized. It should be unique. Disused airfields, for instance, are often easy to see, but there can be many close together. It should have good vertical extent, so that it stands out against the skyline. And it should contrast in colour or texture with its surroundings. However, it is not necessary for it to be directly on track. In fact, it is better if it is a mile or two to the side of track, because, to check the timing, it is easier to judge an accurate beam than a direct visual overhead. It may be difficult in practice to combine all of these features in a single point, and some compromise may be necessary. If you plan your flight well, and then use the map to ground technique properly, you should not get lost. If, despite this, you do find yourself uncertain of position, this is the time to use the ground to map technique. The first thing to do is to check that you are flying the right heading and airspeed. If there are no airspace restrictions and no low cloud, climb to increase your visual and radio horizon. Then try to fix your position using any visual, radio or radar aid. If restricted to visual map reading, then estimate a most probable position. Use your heading and the expected drift to calculate a track. Estimate your ground speed and work out your distance along track from your last known fix. This is called a deduced reckoning position, or DR position for short. Construct a circle of uncertainty around your DR position, using a radius of 10% of the distance flown since the last fix. Now look out of the aircraft and select large ground features. On most occasions, they should be on the map within the circle of uncertainty. If still uncertain, turn towards a good line feature on the map, outside the circle of uncertainty. A line feature has length. Examples are motorways, rivers and coastlines. On reaching the line feature, follow it until you find a definite visual fix point. We have looked at the two basic map reading techniques: map to ground as the normal method, and ground to map when uncertain of position. We saw that an ideal visual fix point should be large, unique, and have vertical extent, and should contrast with its background. But we accepted that sometimes a compromise is necessary, and we established a course of action if uncertain of position. The next lesson will look at some of the more common conventional signs used on topographical maps.